everyone. Welcome to the session 9. So, in this session, we are going to discuss another body part worked example where K is unknown. So, coming to the worked example, a unit feedback control system has G of S is equal to K divided by S into 1 plus S into 1 plus S by 10. Determine the value of K so that gain margin is equal to 12 dB and phase margin is equal to 30 degree. Okay, so here in this case K is unknown. We have to find out K value for these two conditions. When gain margin is equal to 12 dB, what is new K value? Then second case, phase margin is equal to 30 degree, so what is new K value? Okay, then so initially, so K value we are assuming K value is equal to 1. First check whether it is standard time constant form or not. Now this open loop transfer function, it is in standard time constant form. So once it is identified standard constant form, next step, coming to next step, convert this S domain to frequency domain by substituting S is equal to J omega. Okay, get frequency domain transfer function. Replace S by J omega. Wherever S is there, replace by J omega. Now, after replacing J omega, so G of J omega is equal to K divided by J omega 1 plus J omega into 1 plus J omega 10. Converting S domain to frequency domain. Then, coming to step number 2, identify the factors. How many factors are there? Here, K on one pole at origin, then first order pole, then another first order pole. There are four factors in that. So identify the corner frequencies. Okay, K is here, K is unknown. Pole at origin, that is 1 by j omega or 1 by s. First order pole 1 by 1 plus j omega. Here we need to find out the corner frequency. So P1 is equal to 1. The reciprocal of this one is equal to 1 radian per second. Then you consider another first order pole 1 by 1 plus j omega by 10. P1 is equal to 1 by 10. Reciprocal of this will be 10 radian per second. Then plot for magnitude curve and phase angle. Tablet this one. You consider the factors 1 by j omega. What is the magnitude curve? The straight line of minus 20 dB per decade slope and passes through omega is equal to 0 and 0 dB. Then phase angle, as we know, the phase angle is minus 90 degree. Then coming to another first order for 1 by 1 plus j omega. Magnitude curve 0 dB per decade for omega is less than 1 radian. Then minus 20 dB per decade for omega is greater than 1. Then phase angle, it is tan inverse of imaginary part by real part minus tan inverse of omega. Real part is 1, omega by 1. So this will be minus tan inverse of omega by 10. Then coming to another factor 1 by 1 plus j omega by 10. 0 dB per decade for omega is less than 10. Then minus 20 dB per decade for omega is greater than 10. Then phase curve, that is minus tan inverse of omega by 10. That is imaginary part by real part. Tan inverse of imaginary part, that is omega by 10 divided by 1. So that will be minus tan inverse of omega by 10. Then you have to uh, find the resultant slope or to construct the magnitude. 1 by 1 plus j omega. The resultant slope is minus 20 dB per decay. Then where it starts at zero point 0.1 radian per second and next corner frequency. Okay, next corner frequency is 1 radian per second. Then you take another factor 1 by 1 plus j omega. So resultant slope, okay, previous slope is minus 20 dB. Then for this factor, so the slope is minus 20, minus 20, minus 20, minus 40 dB per decade. The resultant slope for this is minus 40 dB per decade. Where its start point is 1 radian per second. Then end. So next corner frequency, that is 10 radian per second. Then you consider another factor, that is 1 by 1 plus j omega by 10. That previous slope is 40. For this, the slope is minus 20, minus 40 and minus 20, that is minus 60. Then where it starts, that slope starts at 10 radian per second, then ends at infinity. Okay. Then coming to phase angle equation. Phase angle equation. You have to tabulate the phase to construct the phase angle part. We have to tabulate with respect to the omega value. Phase angle equation for 1 by j omega. That phase angle we already discussed, that is minus 90 degree. Then for first order pole, that is 1 by 1 plus j omega is minus tan inverse of omega by 1. That is imaginary tan inverse of imaginary part by real part omega by 1. So that will be minus tan inverse of omega by 10. Then you consider another first order pole 1 by 1 plus j omega by 10. The this one, phase angle is minus tan inverse of omega by 10. Then resultant phase angle is minus 90 minus tan inverse of omega by 10, omega by 1 minus tan inverse of omega by 10. This one. Then phase angle, prepare a phase angle table. So you select the omega value for 1 by j omega. This will be always 90 degree. Okay. Then if you substitute omega value here, omega value here 0.1. So this will be uh, minus 5.7 degree. Then omega value is 0.1. Here it is minus 0.57. Then summation of all three minus 96.27 degree. Like that, you have to tabulate for 0.5. Omega value is 0.5. So the resultant phase angle is minus 190.42 degree. Then like that, for 100 the angle will be minus 263.2. Like that you have to tabulate. Like that you have to tabulate. So once you complete, okay, magnitude table and phase angle, you have to go for construction of the magnitude plot as well as the phase angle plot. Okay, now here it is the similar sheet. X-axis is log omega. It is non-linear scale, so that we can accommodate the frequency range, large frequency range. So y-axis is, okay, linear scale. So here for magnitude plot, it is y-axis is magnitude, so that is in decibel. Okay, now you take the 0 dB line. So initial magnitude is 20 dB. Initial magnitude is 20 dB. Okay. So from this point, draw a slope line, that is for 1 by s or 1 by j omega. That is minus 20 dB per decade. From here to here is not this one. From 20 dB per decade. Decade means 10 times, 0.1 to 1. Then you take another factor, that is first order pole. So that the resultant magnitude is minus 40 dB per decade. From this point you count minus 40 per decade. So that will be from year to year it is minus 40 dB per decade. Where it start with the 1 and ends with the 10 radian per second. Then you consider another first order pole. So that resultant magnitude is minus 60 dB per decade. Where it starts at 10 omega value is equal to 10 and ends at infinity. So from this point, this slope, okay, this slope is minus 60 dB per decade. Okay, for k value is equal to 1. So this is the resultant magnitude. Okay. So once resultant magnitude is done, then you have to go for the phase angle plot. Phase angle plot. Now you can see it. So this is the omega value. These are the correspondent resultant phase angle. Okay. Now you draw a minus 180-degree line here. Then plot the corresponding this one omega value for corresponding phase angle. These are the points. Okay, so these are the points. Then so these points are joined by smooth curve. So whereas in case of magnitude plot it is straight line, the phase angle it is drawn by smooth curve. Okay, then so once complete once you complete the magnitude plot and phase angle plot, then you have to find the gain margin as well as the phase margin when k value is equal to 1. Now, okay, so here you consider the resultant phase angle plot where it crosses minus 180-degree. Then draw a vertical line from here towards magnitude plot. Then measure the gain margin when k value is equal to 1. Same way, consider the resultant magnitude here, it crosses here. Then draw a vertical line, okay, vertical line here. Then this will be the phase margin when k value is equal to phase margin. But our objective is to find the new k value for two conditions. What are the conditions? Okay, when gain margin is determine the value of k when gain margin is 12 dB. Okay, one when gain margin is 12 dB, find the new value of k. Now here, okay, gain margin is 12 dB. When k value is equal to 1 from here to here, here to here, here to here, it is 20 dB. Okay. The given uh, uh, gain margin is 12 dB. When k value is equal to 1, then actual this one is 20 dB. But 20 minus 12, 8 dB. Okay, that 8 dB we have to shift from here to here. We have to shift this A to A dash, that is 8 dB. Then draw a parallel line parallel to this line, parallel to this line. Then complete this. Okay, so this line is parallel to the resultant magnitude when k value is equal to 1. Then then find out k value is equal to new gain value when gain margin is equal to 12 dB. Now you can see here, so the difference is 8 GB. Then 20 log k is equal to 8. Then k value is equal to 2.5. When gain margin is equal to 12 dB, k value is equal to 2.51. Similarly, so we have to find out another k value, another case 2 k value when phase margin is equal to 38 degree. Yeah, so I mean phase margin is equal to 30 degree. Now we can see here. So this is the one where it crosses from ear to ear. So this value, the phase margin value is phase margin is 38 degree. But actually we required 30 degree. Okay. Now so this will be 30 degree line. Then done this. Okay. Then we have to shift from ear to ear. So that is 4 dB we have to shift. From ear to ear we have to shift. Then draw a line parallel to this line. That is dotted line. This is the dotted line. Can you see this dotted line? The parallel to the previous resultant magnitude line by considering k value is equal to 1. Then afterwards you have to find out new k value. Now you can see here from graph phase margin is 38 degree. Actual the desired phase margin is 30 degree. Then what is that k value? To achieve this we have to shift this. Okay, so we have to shift this. So B2 from here. So B to B dash. B is this one, B dash is this one. So it is shifted 4 dB. Then consider 20 log K is equal to 4 dB. K value is equal to 1.58. Then phase margin is 30 degree. So new K value is equal to 1.58. Then gain margin is 12 dB. New K value is equal to 2.51. Thank you.